So in this video, we are going to one more interesting algorithm on the jump game. So problem statement is that you have been given one array 6, 14, 6, 4, 14, 6, 8, and this I have arranged that, and you have to jump keeping the conditions in mind, and this d value I will explain how many jump you can do that maximum number of jumps in one shot you have to return. So what is the condition is that, so suppose you can just for the illustration purpose you can think these are the buildings, right? So suppose you are at the index 5. Suppose if you are on the index 5 on this one, right? So if you are in the index 5, I is equal to 5. So from 5 you can go I plus x and I minus x, means keeping the value in mind d is equal to 2. So if you are on the 13, 2 means from 5 to 2, 7, and this side also 3. So from here you can jump this building, you can jump this building, you can jump also this building, you can jump also this building. Means from 5 you can go 6 and 7, in this case 3 and 4, right? So how we can calculate? If I is equal to 5, your current index is 5, so from I plus 1 till I plus d. In this case we have the d is equal to 2, so we have only two values. So I plus 1 means 5 plus 1 6, I plus d 5 plus 2 7. Here I minus 1 to I minus d. So 5 minus d is equal to 3. Keeping in mind this value should not less than 0, right? We have the index only. So this value always greater than equal 0, and this value should always less than the length of the nums array. Nums length. This is the one condition, first and second condition. So according to first and second condition, from 13 I can go the 6. From the fifth index we can go the 3 index, 4 index, 6 index, 7 index. But the third condition is also there. So you can jump only from higher to lower building. You cannot jump from lower to higher building. So this is the 13 and this value is 8, so you can jump. This is the 13, this value is 6, you can jump. This is the 13 building, you can jump to 9, jump to 7. So in this case all the three conditions satisfy and we can jump from 13 to this 4 building. But if you take the example, suppose the 9th, if you here on 9th, your I is equal to 9, suppose. So from 9, how many things you can jump? So there are the two possibilities, right? So if you see I plus 1 to do, so you can go 10, sorry, this is 6 index. If I is equal to 6, according to first and second condition, you can go the 7, you can go the 8, you can go the 5, you can go the 4, right? So from here you can go the 6 to 7, 7 to 8, and 4 to 5, and this 8 is also less than the number of this one. What is the nums length? This is 11, so this is also satisfied, and this is greater than 0, so this is also satisfied. So first and two conditions satisfy. But if you see, the index of the 5 has the more value than the index of 6. So from 9 you cannot go the 13, so you cannot go the 5th index, you is rolled out, you can't go. So as you cannot come to the this one 14, so you cannot also come to the 4th one. So 4th one is also close. Right? Now from here to 7 or 10, 10 has the more value, means index has the more value, you cannot go, only you can go to the 7. So this is the how we have to move. So now again, so suppose if you are on the 9, so how many indexes you can touch? You can touch itself is a 9 and this 7. So for this 6 index you can touch only 2. It himself, this one, and the 7. So their number of jump or touch the index is equal to 2, right? Take the example for the suppose 13. From 13, or take the example for the 7. From 7, how many we can jump? So of course from 7 I cannot jump the 10, I cannot jump the 9 value. So from 7 I cannot touch anything apart from 7. So 7 value is 1. Okay. Now take the example for the 6, or we can start from here. So from the 6, where you can jump. You don't have anything for the left side, we can only jump 1, 4, we cannot jump on the 14. It should supposed to the jump from 0 to 1 and 2 because d is equal to 2, but keeping the condition 3rd in the mind, I cannot jump here, I cannot touch this indexes, so I can jump only. So from 6, I can touch 6 itself, this itself, and this one. So value is equal to 2. For the 4, from 4 I can't jump 6 also, I can't jump also 14 because both have the more than the value of 14. This is the condition for the 3. So here value is equal to 1 because it can only touch himself, not apart from the anything, right? Now from the 14 you can see, this is an interesting one. So from 14 I can jump 4 also, I can jump 6 also, I can jump this 6 also, I can jump 8 also. It satisfies all the conditions 1, 2, 3. Then which you have to choose, from where you can get the maximum jump, right? So from 14, if you come to the 4, from 4 I can't go anyone, right? So if you choose this path from 4, if you choose this path from 14 to 4, from 14 to 4, or if you talk the index wise from 2 to 1, after 4 I can't go anyone. So in this way total jump is equal to 2 only. Take another option. If you take from 14 to 6, so from 14 to 6, and from 6 I can jump the 4, right? So in this way you will have the 3 value 1, 2, 3. From 14 to 6, right? Don't confuse with the value, I'm putting the value. From 14 to this one, and from here I cannot jump anyone. So if you go this way we can only jump the 2. Let me remove this, is creating the confusion. Take the index only. So if you are index 2, from 2 if I go the 1, I can jump 2 only. If you 2 jump index 0, you can take 3, right? From here to here, from here to here. If you take from 2 to 3 index, I can take only 2 jump from here, this one and this one, right? So only the 2 jump. Okay. If you come from 14 to 8, means from 2 to 4, and from 4 I can jump only 1 here, right? So if you take 14 to 8, 8 to 6, so we have the jump 3. You have to choose maximum. Maximum is the 3. So you can say if you jump start from the second, you would have the 3 jump, right? So again I am saying that all the possibilities value, whatever the possibilities, you have to choose the maximum number of the jump, right? Now so come to the index 3. From 3 I cannot go anywhere, so it is only 1 jump. From 8 I can jump only 6, not the 13, so 2. From 13 I can jump, means from 5 I can jump 3, I can jump 4, I can jump 6, I can 7, right? So you have to pick up the more maximum. So 5 plus 3, what is the 3 value? 1. So 5 plus 3 value 1. So 5 plus 5 1 and the 3 1. So it will ending the 2 jump. 5 and the 4 has the 2 value. 5 itself is the 1 and the 4 value is equal to 2. So this is the 3. 6 is equal to 2. So 5 itself is a 1, 6 value is 2. So this is the 3. 7, 5 itself is the 1, 7 is 1. So you can 2 value. So out of this, it is the maximum is the 3. So I can put 3. So if you start jumping from the 5th index, you can maximum touch the 3 buildings, right? Come to the 8. So if you take the 8, see from 8 how many jump you can do. So from 8 you can jump this building, you can jump this building, you can jump this building, right? So from 8th index, you can jump 6, you can jump 7, and you can jump 9. What is the 6th value? 2. 8 is 1 value and 6. 1 plus 2 is equal to 3 building you can jump. 7 value is equal to 1. So 8 himself is a 1 plus 7 1. So you can go 2 value. 9 value I don't know. So you can't calculate the 8. First you have to go find out 9, then you have to come back on the 8. So let us move to the 9 part. Keep the 8 is empty. So from 9 I can't move anywhere, right? So this is the 1 value. Now come back to the 8. 8 himself 1 and 9 1 2. So what is the maximum here? Maximum is equal to 3. So 8 value is the 3. Let us check for the last one. Here, from here where you can jump. You can jump from 12, you can jump the 6 and you can jump the 10, because right side there is no options. And then from 10 you can jump either 8 or 9. 10 itself is a 1 value and 8 is the 3 value. So total is equal to 4. 10th itself 1, 9 is equal to 1. So 2 is maximum 2. So 10 is the 4 value. So output of this question is the 4, because if you jump from 10th, you can touch the 4 building. Let me see how. From 12, you can come to the 10, right? This is the 1. So from 10th index, you can come to the 8th index, right? And from 8th index, you can jump to the 9 index, and from 9 you can jump into the 7 index. In this way is the 4, right? So hope you have already understand the questions. Let me do the coding, how we can do the code part, right? Code is also very simple, not much complicated, but let me show how you can do that. So what we do? We do the recursion. So first we come the 1. To find out 1, I need the 1. If you start from 0, to find out the maximum jump for the 0, you need the 1 index, right? So I will find out what is the maximum jump of 1. Again, if you go for the 2, to find out the maximum jump, we have to go on the 1, 0, 1, 3, 4. So we visit all the dependent, then we can calculate maximum for the particular index. So let me do that, how we can do. So we use the recursion, means depth first search, and we also improve through the memorization. How we can do that? Very simple. You run from here to there, from here to the length. So what you do? From 0 to nums length. And take the one array max, means how much maximum jump we can take. So for the time being, put the 0, and max value would be the math of x. Here is a little bit important, max. And so what I am doing, that I will run from here. Starting time max is 0. So I will calculate for the index 0 how much jump you can do that. If number of that jump is greater than this max, I will swap. So in the max, I will keep the maximum jump. But if you start from 0, I don't know how much jump we can do from 6, right? So you will use some helper method and keep the method name count max jump. This is my method. It will return the integer. And what are the things I have to pass here? Of course, you need the array, that nums. And for which index you want to calculate? I need the I, means which the current index. And of course, you have to pass the d value, because we have to put the conditions for the next value, right? What is the height and all those things, where you can go left and right. For that I need the d value. So every time you have to call this method, count, max jump, and pass all the three parameters. In this case, nums I and d, and return the max. Now the important this method, how you can achieve this. So when you want to find out the maximum jump for any index, suppose I want to find out this one index, so we have to find out the result. So it himself is the one, right? As I am saying that for the each building has the value at least one. So what I will do, make one variable result and keep the value 1. And if you are in the index 5, you visit all those sides here or those sides that I have already explained. So if you go from the 5 left side, so your for loop should be start from I minus 1 till I minus d. Here I plus 1 till I plus d. And this I plus d should always greater than 0. It should not come here. So this is the first condition, always greater than 0. It should not less than the I minus d, should always greater than 0, 2. And third condition, this value should not greater than this one. So this value means nums always greater than with nums k value or j value, whatever. Let me explain here. So first run that loop from here to here. So that for loop j is equal to start from I minus 1, it will go I minus d, comma, j value should be here, should be greater than equal I minus d, okay, and we will do the j minus minus because I am coming from here to here, reducing one step, right? And this value should be greater than that. Again, one more condition, this value you have to choose either the I minus d or the 0, which is the maximum, right? So it should not go back there. So here you have to choose maximum of both of this. What is the maximum? That is the condition for the j. Another condition, that this is the nums I, right, and this is the nums j. So nums I should always greater than nums j. It will loop from here to here, from here to here. It should not get less than 0. So I will take the maximum of both of these, which is the maximum. I will take that. And for the third condition, this value should be always greater than or the visiting one. In that case, what I will do, I have the result. Here again, I will take the max math. Why? For this 13 case, I will have the 4 result. 1 result, 2 result, 3 result, 4 result, and I have to choose the maximum out of the 4. So that's why I use the math.max and I will choose the result and the previous result and the current visiting element. What is the current visiting element? This one. So for that one we have to find out the jump. So again you have to call this method recursive count max jump, and you have to pass this time j, means the nums, then j, and then d. But when you see the comparison always I am adding 1 plus here, right? So you have to add 1 plus. That's it. It is for the left side. Now we have to do the same thing for the right side, that we will see in the code. Same thing for do the right side and return result. That is the algorithm that we will do that. But suppose if you have this array is very big, 1000 element, then you should use the memorization. So you will create one array of the same size, kind of this one, and I will keep all this value. So we should not again calculate the number of jump for the particular indexes which have already visited, which we have already calculated. So what I will do, I will take one dp of the same size of the num size, and whenever you will find out the result in the dp, I will keep this result, and before calculating here I will check if that value is already there, then we will not do calculation. If it is not there, we will do the calculation and keep the value in the result. So little bit complex, but I hope if you see the video 2-3 times and go through the code, then you might be crack it out. So let us go to the code side. From I to maximum num7, right? And as I say, we keep one max value, right? So keep one max, put into 0, and here in max we will check the maximum of the surrounding area, right? So between max and I have one helper method, that is the count max jump, and I have to pass, as we discuss, nums I and d, right? And then we return the max value. Now we have to make this value method, and we have to pass 3 things: one, the array, and other indexes, means the current indexes that I have used as I here, right? So you can use any name, and of course d would be passing there. And as I discussed, we have the one result. So result keeping the value 1 because itself is a 1 value. Then I will go for the left side, then we will go the right side. So go for the left side first. I and j equal to, it will start from index -1. It will should be greater and equal index -d. But this index limitations, we can only go till 0, not less than the 0. So we can keep one the max. Either we can consider this value or the 0 which is the greater, right? And we have to also one condition, and nums index should always greater than what is the current running j value, right? And then the j minus minus. Again do the same thing, result for the max. If result is greater, existing result is greater, we take the result. Otherwise you will take the, again we will call the same method, count max, and pass nums. This time my index is j and the d. That's it. And we have to do the same thing for the right side. Right? This is for the left side and this is for the right side. This time we start from index +1. It would be the less than equal this value plus d compared to nums length -1, because you have taken the equal here, and this condition would be already there, and here would be the j++. Yes, and of course I forgot put the 1 plus, because every time in the calculation we are taking the 1. That would be also here, and here we return the result. That should be sufficient. Let us run, it's working or fine or not. So if you run that, check, some error is there. Let me check what is the error. Cannot find the symbol. Which symbols? th, it's by mistake. Yeah. Okay, so some conditions, this value should be less than not the max, this should be min, right? whatever the mean. It is a maximum index or maximum length or the I plus index, right? So this here should be the max and here should be the mean, right? And now it is working fine. But when you submit the code, you will get some error, runtime error, because in this cases might be you have the huge number of the indexes, right? So for that you have to go the memorization things. So take one dp, and here we initializing the dp with new int and take the same size, okay? And then when you returning the result, that time itself in the index you keep result as a safe result, and no need to calculate every time when you in this command the method. We check if dp index has greater than 0, right? So then that means we have already solved this value in the past. So just return the dp index value. That's it. Let me run the code again and see it is working fine or not. Where it is saying that return spelling mistake was there. It's working fine. Now it is submit the code and see whether this is accepting or not. It is accepted. 12 milliseconds taken. Thank you very much. If you have any questions, let me know. I will try to give the answers. Thank you.